Hello students, yes we are right now and this is our fourth video lesson of chapter number 3, isn't it? So today we will discuss about what? In the last class we have discussed about what? In the last class we have discussed about the structure of atoms, molecules and how does these molecules form and different characteristics of the molecule, isn't it? So in this class we will discuss about Dalton's atomic theory, okay, in which we will see that what are the different characteristics of the atoms, molecules which are going to be formed, okay, and the basic character of the atoms, molecules and compounds and the mixtures that has been postulated by John Dalton, okay. So let's see what is this concept says. So today we will discuss about Dalton's atomic theory which is postulated by John Dalton. So what does this Dalton's atomic theory says? This atomic theory says that all the matters, elements or compounds or mixture are made up of very tiny particles, very tiny, very small particles. What are those? That is atoms. Okay, that's nothing but atom. So let's see what are the different characteristics among them. So first, let's see the similar atom. What does the similar atom says? Okay, what are the different characteristics of the similar atoms? If we will take two similar atoms and we will observe that what are the size, shape and the different characteristics, physical characteristics, chemical characteristics of the atoms, whether that is similar or dissimilar. Okay, let's check this one. So here two atoms we have taken, atom A and atom B, and these two atoms are nothing but for element iron. Okay, it's for iron. So these two atoms say that let's measure our size, and they see that you can see over here that the size is similar. So what is the conclusion over here? That the shape and size of the atoms of two similar elements is nothing but similar. Now they try to measure their mass, okay, and they saw that the mass is also similar. So similar elements have the atoms, they have the same size, same physical property and same mass also, okay. So now let's check for the different elements. Different elements like one is iron, let's take a sulfur, okay. So iron and sulfur. Now let's see whether they have the similar size and shape and the characteristics or not, okay. So let's measure the size, okay. How they have measured? Here sulfur says that, okay, let's see your volume or your size. So the size of iron as is greater than sulfur. So here we see that the similar element have different in their size, okay. This comes in the conclusion. Now we want to say that let's check the weight, that let's measure our weight, whether our weight is similar or not, okay. Now let's see. So in this case also they show that what happened, the mass of the iron is much greater than sulfur. That this is the conclusion that they have different mass. Clear? All got this part? So this is the second part of Dalton's atomic theory. And what is the conclusion over here? That they have, this similar element have different mass. Clear? And what is the third point? That third point is that atoms can neither be created nor be destroyed. They are the indivisible particle of an element. Okay. So here you can see over here that the iron particle, atom of an iron, this says that I am indivisible, and at the same time sulfur is saying that I am also indivisible. At the same time the product ferrous sulfate, okay, FES, that is says that you can neither be created nor be destroyed, okay. And he says that but the molecule that can be recombined, okay, that is combination of iron and sulfur that get combined to form this ferrous sulfate, isn't it? Okay. So here we get the conclusion that the elements or the matters can neither be created nor be destroyed, only they are the smallest or tiny particle of the element or compound, okay. But the molecules can be divided into the atoms. Clear? So here we observe that the combination is fixed for a particular molecule. This is nothing but our third point, that the shape or the size of the molecules or the combination of the molecules is nothing but it's similar. They combine by the atoms which is fixed, or the ratio between between the atoms which has been combined to form a molecule, that is fixed. Universally, that is fixed. Here you can see that ferrous and sulfur, they has been combined in 1:1 ratio, and that ratio for ferrous sulfate is nothing but that is universally fixed. We can never change the ratio. Okay, for ferrous sulfate, this ratio, this 1:1 ratio, this will be fixed for always. Each time if we will see the combination of iron and sulfur in ferrous sulfate, then that will be fixed. Clear over this point? Now what is the conclusion over here? That in a chemical reaction, atoms only get rearranged. In a chemical reaction, atoms can neither be created nor be destroyed. They only get rearranged. That means to say what? That the shape and size, only we will observe that they are not going to change their number of atoms or anything else. Only they will be get rearranged. Okay, they will get combined or they will get deviated or they will break down some bonds. Okay, this is what happens in a particular chemical reaction or a physical reaction. Okay, this is what the Dalton's atomic theory says, that in a particular molecule the atoms are just only get rearranged for formation and they get divided for any decomposition reaction. Next point of Dalton's atomic theory says that what does this say? It says that the atoms get recombined to form a molecule, and these atoms can neither be converted into another atoms like by using their number of electron or number of proton. They only get rearranged. They only shift from one place to another place to form different types of molecules. Right? So for example, let us take here sodium hydroxide. Here the sodium break the bond with OH group. Okay, hydroxide group, that break the bond. Sodium has break the bond with OH minus group, and this is just react with the chlorine part. Okay, it's nothing but Cl minus and it's Na plus. Okay, Na plus means it has the tendency to donate an electron, whereas the chlorine has the tendency to accept an electron. Right? So what happens? That sodium and chlorine get react to form sodium chloride. It's nothing but sodium chloride, right? And the water part, how that has been formed? That OH group has reacted with H plus ion. H plus ion from HCl. Okay, so HCl has been divided into two parts. What is that? The cationic part is H plus and anionic part is Cl minus. So this H plus part has reacted with OH minus part, the cationic part, and that get reacted to form what? One water molecule. This one water molecule, it's product of the H plus and OH minus group, which is present in NaOH hydrochloric sodium hydroxide, which is present in NaOH sodium hydroxide, and the H part which is present in hydrochloric acid. Clear all over this word? So what is the basic concept or basic gist of Dalton's atomic theory? We came to know that atoms are indivisible particles and similar elements atoms have the same atomic size, mass and chemical and physical properties also. And also we came to know that the atoms are indivisible and they never used to convert into another types of atom by losing their electron or losing their proton. Okay, and the next point what we observe over here, that the molecule elements or compounds, they form by combination of the atoms by a certain fixed ratio. Okay, they have a fixed ratio by mass. That ratio can never be changed. If that ratio will be changed, then the product will be also changed. Clear? So I think all of you have been crystal clear about Dalton's atomic theory. If you are having any doubt, you can ask me anytime. Feel free to ask. Thank you, dear students. Take care, stay home, stay safe.